Hi, hello students, good evening everyone. I hope I am perfectly audible and visible to each and everyone present over here. Okay, anyway, welcome back all of you to the Infinity Learn JEE YouTube channel. This is me Surya, your chemistry faculty from Infinity Learn. Hi Priyanshu, good evening. Okay, we will be moving to our new chapter in the grade 12, that is the biomolecules. Before that, there is a general reminder about the AATS, all India test series. You will get a 50% discount by using the coupon code of U250 off. I hope everyone enrolled the course first. If anyone missed, just enroll fast. Hi Muhammad Sami, good evening. Okay, we can directly move to our topic, that is the biomolecules. What do you mean by biomolecules? Something related to biology, right? Yes, in this particular session, we will be discussing about the chemistry of some different molecules which is related to biology. Right, so this is a part of biochemistry. We will be moving to the biomolecules. So, in the whole chapter, we will be discussing about these different types of biomolecules. We are starting from the carbohydrates, then moving to the amino acids and proteins, enzymes, vitamins, and finally moving to the nucleic acids. In today's session, the particular session we are focusing on the carbohydrates only. Ready? Okay, let us start about what you mean by carbohydrates. Okay, you must have an idea from the name, right? Carbohydrates. It is something related to hydrates, related to carbon. So we can define as the carbohydrates mainly contains carbon, hydrogen and oxygen. Yes, carbon, hydrogen and oxygen. And from the name itself, it is identified that, or it is meant that it is the hydrates of carbon. Hydrates of carbon having the formula of CxH2O times, right? So let us take some examples. As you already know, the glucose, right? Glucose, it is having the formula of C6H12O6 or C6H2O 6 times, right? This is a general formula. Then the second one, it is the sucrose. Sucrose having the formula of C12H22O11 or C12H2O11 times, right? It follows the general formula of CxH2O times. So we can call it as a carbohydrate. Clear? Yes. So generally, the carbohydrates, as we already know, glucose, sucrose, right? Sucrose stands for the sugar cane sugar. So we can say that all the carbohydrates are sugar taste, right? Sugar taste, otherwise known as sweet in taste. So it is called as saccharides because saccharine means sugar, right? Clear? This is a simple introduction about the carbohydrates. Now we will be moving to the classification of carbohydrates, right? Based on different criteria or the parameter, we can divide the carbohydrates into different classifications. As you can see over here, this is the first classification, right? Yes. Based on the hydrolysis product, based on the number of hydrolysis product, we can classify the carbohydrates into three or different types. As you can see over here, first one it is the monosaccharides, oligosaccharides and polysaccharides. We will be discussing in detail in the next slides. Then based on the reduction properties, right? Based on the reduction properties, it is again classified into reducing sugar as well as non-reducing sugar. Then about the configuration, based on the structure or the relative configuration, the glucose, not only glucose, all the carbohydrates can be classified into D form and L form. Okay, this is all about the just introduction about the classification of carbohydrates. Let us talk about the what you mean by the classification based on the hydrolysis of products, right? Hydrolysis of products. Okay, we can classify the carbohydrates based on the number of hydrolysis of product. Can be classified into three types. What are they? Three types, right? Okay. First one, it is the monosaccharides, then disaccharides and oligosaccharides, right? Let us see what you mean by monosaccharides. What you mean by mono? It refers to number, right? As I already mentioned that it is based on the classification. However, how much number of products are forming, right? So if any of the carbohydrates undergoing hydrolysis to form only one type of molecules, right? Mono means one, or we can say that the basic unit of carbohydrate, it will be the basic unit of carbohydrate which cannot be hydrolyzed further. Glucose cannot be hydrolyzed further. Similarly, fructose also. So we can say that glucose and fructose are the examples of monosaccharides, right? Yes. Priyanshu, mono means one, right? So mono means one. So we can say that it is the simplest unit. Simplest unit. It cannot be hydrolyzed further. So we can say that glucose and fructose are the examples of monosaccharides, right? Clear? Now, what about the disaccharides? Based on the number, you can have an idea, right? Di means 2, right? Di means 2, which means that whenever any of the carbohydrates that undergo hydrolysis, it will form two types of monosaccharides. Two types of monosaccharides. Such carbohydrates, such classification of carbohydrates are known as the disaccharides. Di stands for 2. Clear? Let us see some examples here. First one, it is the sucrose, maltose, lactose. We will be discussing the structure as well as properties of these three types of disaccharides in detail in this particular session. Then, next about the third classification, right? Oligosaccharides, which means that whenever they undergo hydrolysis, they will form more monosaccharides, right? More than 2 monosaccharides. If they form 2 monosaccharides, they call it as disaccharides. If they form more than 2 monosaccharides, they will known as oligosaccharides. Clear? Oligosaccharides. For you can say that 3 to 10 number of monosaccharides are forming on hydrolysis of oligosaccharides, right? Clear? One of the example which is given here, it is raffinose. Raffinose is a type of oligosaccharides which will undergo hydrolysis to form glucose, fructose and galactose at the same time. Right? Clear? As Priyanshu, we will be discussing later. If more than 10, what will happen, right? I hope these things are clear for everyone. Now we will be moving to the next topic. If the hydrolysis happens, if they form more than 10 products, right? More than 10 products, what will be called as? They are called as polysaccharides. Whenever the carbohydrates that undergo hydrolysis and they form more than 10 or more than 10 monosaccharides are known as, more than 10 monosaccharides are known as polysaccharides. Clear? Okay, raffinose, right? Raffinose is a complex structure. We can say that whenever raffinose undergoes hydrolysis, they will be forming 3 types of monosaccharides: glucose, fructose and galactose. So, they are also known as trisaccharides. Right? Clear? Priyanshu? Okay, fine. Now we will be moving to the polysaccharides, right? Whenever the not carbohydrates, whenever they undergo hydrolysis and form more than 10 monosaccharides, they are called as polysaccharides. General formula is C6H10O5 N times. Examples are starch, as we already know, cellulose, right? Glycogen, animal starch, dextrine, gums, etc. are the examples of polysaccharides. Clear? As we already see the classification of carbohydrates as based on the hydrolysis products, right? So we are classified into oligosaccharides or the mono, di and oligosaccharides, and last one it is the polysaccharides. Based on the properties, we can be defined it as sugars and non-sugars, right? Sugars and non-sugars. What are the properties there? If we are considering mono, di and oligosaccharides, we know that mono, di and oligosaccharides, they are crystalline solids and they are soluble in water. For example, if you are taking glucose, it is soluble in water, right? So it is sweet to taste and they are called sugars, right? All the mono, di and oligosaccharides are known as sugars because they are sweet in taste, soluble in water and crystalline solids. Then what about the polysaccharides? Just opposite there, right? They are colorless, amorphous solids and generally insoluble in water, insoluble in cold water. And they are tasteless, so they are known as non-sugars. Clear? Okay, I hope you have studied about the solid chemistry, solid state chemistry, right? You have studied about the crystalline solids and amorphous solids. It's not about acidic and base. Acidic and basic means, I hope you have a doubt about the amphoteric, right? It's not about amphoteric, it is the amorphous structure. We can say that whenever you are taking any of the sugar or something like, it's like a crystal-like structure. If it is not having the crystal-like structure, we can simply say that they are amorphous in nature. And it has many deep meaning in the solid state chemistry. Clear? It's not about acidic or basic. Fine? Okay, fine. So first classification we have done about the hydrolysis of products. Now we will be moving to the classification of carbohydrates based on their reduction properties, right? Based on their reduction properties, tendency to undergo reduction. So I hope everyone have the idea about the reducing agents, right? Reducing agent. So whenever we are discussing about the laboratory technique, there are some reagents, right? Tolerance reagent and Felling's reagent. Yes, tolerance reagent and Felling's reagent. Whenever any of the carbohydrates that will undergo reduction by using these reagents, they are known as reducing sugars. They are known as reducing sugars. So we can say that the carbohydrates which reduce tolerance reagent. Tolerance reagent means it is a, simply I can say that this is the ammoniacal silver nitrate solvent or the reagent. Whenever we are treating with any of the glucose molecules, we can say that there will be silver mirrors formed in the test tube. You can just check into YouTube also, you can see the good demonstration about the tolerance reagent test. It is a beautiful silver mirrors forming on the tolerance reagent test of the glucose. Right? Examples like all the monosaccharides and disaccharides except sucrose are the examples of reducing sugars. Then what about the non-reducing sugar? Whenever we are treating with the tolerance reagent or the Felling's reagent, we can say that it does not give any positive result. So we can say that they are non-reducing in nature. They are non-reducing in nature. For example, sucrose. Clear? These are the second type of classification of carbohydrates based on their reduction properties. Clear? Just let me know so that I can move to the next part. Okay, fine. Next is the third type of classification based on the structure or the relative configuration of compounds, right? So we can classify these sugars as D and L forms based on their relative configuration. For example, if I am taking if anyone have the idea of about this compound, what this compound names, any idea? It contains an aldehyde group, right? CHO, and it is again contains CH2OH group. So this compound is known as the glyceraldehyde, right? Glyceraldehyde. This is the basic structure of glyceraldehyde. As you can see over here, I have highlighted here, right, by using a red mark. This is the hydrogen is around the left side and OH is around the right side. And for this one, it is around just opposite, right, which means that this is the L-glyceraldehyde. So, whenever we are having any of the carbohydrates, we can just connect it or compare it with the structure of glyceraldehyde so that we can just imagine or just giving the name of the particular compound as D form and L form. Clear? So, the sugars having the same configuration as D-glyceraldehyde at the last chiral carbon. I hope everyone have the idea about the stereochemistry, chiral carbon, right? If the carbon containing 4 different surrounding atoms or surrounding groups are known as the chiral carbon. So, if the compound containing the last chiral carbon that has the same configuration as that of the D-glyceraldehyde is known as the D sugars, and if it is having the same configuration as that of the L-glyceraldehyde is known as the L form of the particular carbohydrate. Clear? These D and L are represented as capital D and capital L. Okay, whenever you are getting any of the molecule, you can just identify the structure. Consider the last carbon atom, right? Consider the last carbon atom. Yes, last chiral carbon atom, which is having the similarity with the D-glyceraldehyde or L-glyceraldehyde. Then it is named as D carbohydrate, whether it is glucose or fructose. Clear? Fine. There will be another one more configuration or one more term you have to be remember that based on the rotation of light. Okay, this capital D and capital L stands for the structure of glyceraldehyde. We are just comparing the structure of glyceraldehyde only. I will be discussing about this rotation, right? Rotation, that is right or left. As you can see over here, enantiomers which rotates the light to the right. If it is rotating the light to the right side, we will be calling it as dextrorotatory or D. Dextrorotatory or D. Otherwise, it is also termed as plus. Right? Then, if the compound is changing or rotates the particular light into the left side, it is termed as minus or L. L stands for levorotatory. Priyanshi, is that clear? Okay, if you are saying capital D or capital L, it stands for the structure about the glyceraldehyde. If you are seeing either plus minus or small letter DL, it stands for their rotation. Clear? Okay, fine. Now we will be discussing about the classification of monosaccharides. We have already seen some examples of monosaccharides, right? Now we will be moving to the deep into their structures. So before that I have to give an idea about that. The monosaccharides have been classified into 2 types. What are they? If they are containing aldehyde groups, along with the hydroxy group, it is known as polyhydroxyaldehydes. No need to worry, whenever we are discussing about the complete structure of glucose, we will be explaining each term around this. Clear? So, if the compound is having optically active aldehyde, polyhydroxyaldehyde, they call it as aldoses. Stands for aldehyde, right? Then what about the ketone group? If they are containing optically active polyhydroxy ketone groups, they are known as ketoses. For example, I am taking it as glucose. If you are taking about the structure of glucose, you can see that there will be a aldehyde group present in the case of glucose. Then similarly, in the case of fructose also, you can see a keto group along with the polyhydroxy. It contains a polyhydroxy keto group, so it is known as ketoses. Clear? Then based on the number of carbon atoms also, we can just name the carbohydrates as triose, tetrose, right? Triose, tetroses, pentoses and hexoses, right? Tri stands for 3, tetra for 4, right? Yes, tri for 3, tetra for 4, pento means 5, hexo means 6, right? So that we can name the carbohydrates based on their functional group. Whether it is containing aldehyde, we can call it as aldoses. Whether it contains ketonic group, we can call it as ketoses. Based on the number also, we can classify them. Clear? Why not die, right? It's a good question. Let us see. While discussing about the structure, right? Priyanshu? Okay. Now we will be moving to the detail about the glucose, right? Glucose. As we already know glucose. What do you mean by glucose? It's about grape sugar. Normal name is called it as the grape sugar. And it occurs in the free form and combined form as in starch, cellulose and sucrose, right? In general, it is occur in the free form, but whenever it is contained in the starch, cellulose or sucrose, it will be containing as a combined form, right? Now, glucose occurs as dextrorotatory. So, what will be their sign? Whether plus or minus or small letter d or small letter l? Priyanshu? Glucose is always dextrorotatory, which means that it always rotates the light into right side, right? Yes, clear, right? Okay, fine. Dextro stands for D, right? D or plus. So, whenever we are taking any of the glucose structure, it must be small letter D glucose. Are you sure small letter D or capital letter D? Small letter D, right? Okay, whenever we are discussing about the rotation of the light, it will be stands for small letter D only. Now, so these glucose are also known as dextrose. Never D and capital, small d and capital D are not same. Okay, small d means it's about the rotation. Capital D I can see from this structure only. Okay, we can say that glucose is always dextrorotatory, so it is known as dextrose. Now, in human blood also it contains some amount of glucose, right? So it is also known as blood sugar. It is also known as blood sugar. Now you can see the structure of glucose here. Yes, structure of glucose here. This is the aldehyde group, right? Aldehyde group. So I can call these compound as aldose, right? Aldose, because of the presence of aldehyde group. These OH groups are known as the hydroxy group. It contains more than 2 or 3. How many OH groups are there? 1, 2, 3, 4, 5, right? 5, which means it is the polyhydroxy aldehyde group. So I can call it as an aldose. Then how many carbon atoms are present here in the case of glucose? I just want to know whether it is hexose, pentose, triose or tetrose. Just count the numbers of carbons. First carbon, right? CHO. First carbon, second, third, fourth, fifth and sixth. Which means that this glucose contains 6 carbon. So I can call this carbon as hexose also, right? Is there any doubt? Hex stand for 6. Yes, fine. Okay, Priyanshu, no, it's okay. Is the thing clear now? How we are calculating the number of carbons and along with their name, hexose or pentose. Yes, we have to count carbon, right? Okay, this is stand for CHO. CHO means aldehyde group, right? There will be 1 carbon atom here. Then this is the Fischer projection formula. I hope everyone have the idea about the stereochemistry or the how to write the Fischer configuration of the different compounds. And these are stands for the carbon atoms. These are stand for the carbon atoms. Okay, this will be first carbon, this is second, this is third, this is fourth, this is fifth, and one more carbon is there in the CH2OH, right? So 6, which means that these compound contain 6 carbons, so they are known as hexose. Clear? Okay. Now I have a question for you. How we can identify whether this compound is capital D glucose or capital L glucose? Capital D and capital L. Okay, whenever we are discussing about the configuration about capital D and capital L, we will be just combining it with the structure of glyceraldehyde, right? Okay, this will be our basic structure. Okay, this will be our basic structure of glyceraldehyde. It stands for D-glyceraldehyde, right? So whenever we are combining with the structure of D-glyceraldehyde, you can see that this is similar to the D-glyceraldehyde, right? Which means that we will be considering about the last chiral carbon. This is our chiral carbon. Just comparing with the one more carbon here. One is OH, one is hydrogen, and there is another carbon, right? Different carbon, right? So this is the last chiral carbon here. According to this last chiral carbon, we can say that it is similar to the structure of D-glyceraldehyde. So it is called as D-glucose. Now, if you are considering the L-glyceraldehyde, it has the same structure that of the D-glyceraldehyde. So we will be L-glyceraldehyde. So we will be calling it as L-glucose. Clear? Are you getting my point? Yes. Whether you must have an idea about the glyceraldehyde structure, or you must remember about the OH structure also. It will be fine. If OH is on the right, it will be D, right? Just like that. Clear? Yes, fine. We have already seen about the structure of glucose, right? Now we have an idea about how to prepare this glucose. How we can prepare this glucose. The first method is from the sucrose. I hope everyone knows about the sugarcane, right? Sugarcane. So sugarcane is containing the carbohydrate of sucrose. From the sucrose, by the hydrolysis of the, acid hydrolysis of the sucrose, we can prepare glucose along with fructose. So the first method to prepare carbohydrate of glucose is the sucrose is boiled with dilute HCl or H2SO4, any of the acid, in the alcoholic solution. We are using here ethanol. The ethanolic solution of acid is used here. So we are giving glucose as well as fructose is the product here. Now the second method for the preparation of glucose from the starch is the commercially preparing method. Commercially, glucose is obtained by the hydrolysis of starch. Right? Hydrolysis of starch by boiling it with dilute H2SO4 at a particular temperature 393 Kelvin and under pressure of 2-3 atmosphere. This is the commercial method of preparation of glucose from the starch. Clear? Okay, fine. Now let us discuss about the next type of monosaccharide, that is the fructose, right? Fructose means fruit sugar. This is the carbohydrates or sugar which is present in most of the fruits. So they're known as fruit sugar. So the naturally occurring fructose is levorotatory. So they are known as levolose. The glucose is dextrorotatory, so they are known as dextrose. Here it is levorotatory. Small letter L, right? Small letter L or minus. So it is called levolose. Now just discuss about the preparation of fructose. Whenever we are doing the acidic hydrolysis of this particular compound, that is inulin, the structure is very difficult. It's a little bit complex. So you must have an idea about the name of this particular compound. Which compound gives on hydrolysis, which compound gives fructose only on hydrolysis? It is the inulin compound, right? Inulin compound. Inulin on acidic hydrolysis gives only fructose. This will be the one method of preparation for the fructose. Clear? The second one is the method of preparation from the sucrose. As we already know that it is the method of preparation of glucose also, right? Along with the glucose, we will get fructose as one of the product here. The same method here, C12H22O11, which means sucrose, right? Sugarcane. Sucrose from the sugarcane. Whenever it is undergoing acidic hydrolysis, it will form fructose and glucose as the product. Clear? Now let us see about what about the structure of fructose. What about the structure of fructose? Okay, I have a question about you, whether this compound is an aldose or ketose. Just gone through the structure. This is the structure of fructose. Just gone through the structure and identify whether it is having aldehyde group or ketone group. Then give me the idea that whether it is a ketose or aldose. Ketose or aldose. What about these? Yes, correct. Ketose, right? As you are correct, Priyanshu. It contains ketone group, C double bond O. So we can call this compound as this particular fructose structure as a ketose group, right? Ketose group. Then what about the number? Just count the number of carbon atoms. Just let me know whether it is the hexose, pentose, triose, tetrose, or anything else. Count the number of carbons. Yes, number of carbon it is 6. What will be the name of this particular compound? Based on the number of carbon atoms, we have given some names, right? Hexose, pentose, septose. It is again hexose because of the presence of 6 carbon atoms. Now, we are just comparing the structure along with the D-glyceraldehyde. As you can see over here, the last carbon atom, last chiral carbon atom have the similar structure as that of the D-glyceraldehyde. So, this fructose is known as D-fructose. D stands for capital D. This is the structure of D-glyceraldehyde. As you can see over here, this is the same structure, right? This structure is similar to this structure. So we can say that this is the D-fructose form. This is D-glyceraldehyde. Similarly, you can draw the structure of L-fructose also. If you are familiar with one of the structure, you can draw the L form also. Just change the configuration of H and OH. Right, this will be the L form. You can see that OH and H have the different configuration as compared to the D fructose. So we can call these as the L fructose. Clear? Okay, fine. So far we discussed about the types of monosaccharides, right? We have discussed about the structure of glucose and fructose. Now we will be moving to the classification now, or the structure of different disaccharides. Structure of disaccharides. Okay, no need to worry about the capital D and small d. If you are seeing capital D or capital L, it is about the glyceraldehyde structure, right? You can just focus, keep on practicing the structure, then you will get an idea. Then small d and small l stands for the optical rotation. It will be in the stereochemistry topic. Keep on practicing to draw the structures, then it will be fine. Otherwise, it will be confusing. Right? Ready? Okay, fine. Now we will be moving to the disaccharides. Disaccharides, as we already know, each one hydrolysis from two monosaccharides. For example, examples are given as sucrose, maltose and lactose. So, in this particular case of disaccharides or the polysaccharides, there will be, you will see a new term here. It is about the linkage that is known as the glycosidic linkage. This is very important about your JEE Main exam perspective, because you must have an idea about what you mean by glycosidic linkage. What are the different types of glycosidic linkages in different types of molecules? Example in sucrose, maltose and lactose. Right? So, whenever two monosaccharide units linked through the oxygen atom, by the laws of a water molecule, a bond is forming. That particular linkage or bond is known as the glycosidic linkage. No need to by heart this definition. You will get an idea about the structure here. So, we will be discussing about the sucrose here. Sucrose is having the general formula of C12H22O11. C12H22O11. So, here right. So, this is the structure of glucose. This is the structure of fructose. This will be the another type of structure that is known as the Haworth projection formula. We will be discussing in detail about the next class, about how to draw the cyclic structure of glucose and fructose. Okay, we are taking here glucose, right? Glucose. From the structure of glucose, we already know that. Okay, there will be OH group, right? There will be one OH group. This is the structure of D-glucose here. Then this is the structure of fructose in the cyclic form. Again, here is also having the OH group, right? Already it is also having the OH group. Whenever these two monosaccharides combine together, I can say that there will be loss of water molecule. There will be a loss of water molecule. These OH and H will combine together to form a water molecule, to form a oxygen atom in between. Clear? That oxygen bond linkage is known as the glycosidic linkage. Clear? Just let me know. Yes, glucose plus fructose is known as the sucrose. Whenever sucrose undergo hydrolysis, it will form glucose and fructose. Clear? Now I am just going to the numbering of the carbons here. 1, 2, 3, 4, 5, 6, right? Again here is also 1. Right? Numbering the carbon, you can say that first carbon atom of the glucose combined with the second position of carbon atom of the fructose to form a 1,2 glycosidic linkage. 1,2 glycosidic linkage. Right? C1 of alpha glucose and C2 of beta fructose. C1 of alpha glucose and C2 of beta fructose. This alpha and beta stands for the isomers, right? Whenever we are discussing about the structure in detail, you will get an idea about that. So, in the case of sucrose, there will be a 1,2 glycosidic linkage between alpha glucose and the beta fructose. Clear? Yes, fine. Now, sucrose is again a non-reducing sugar. It does not give any positive result with the Felling's test as well as tolerance test. Now, the second type of disaccharide is the lactose. Second type of disaccharide is the lactose, which is the common carbohydrate shown in the milk. So, it is known as milk sugar. It is known as milk sugar. The combining compounds in the case of disaccharide lactose is known as the beta D glucose and beta D galactose. Beta D glucose and beta D galactose. As you can see over here, this is the structure. Okay, this first one is the galactose. This one is the glucose. Galactose and glucose are the same type of molecules having a similar chemical formula. Only difference is, I am discussing about the galactose only. Only difference about the galactose and glucose is that it is having the change in position of OH and H in the fourth position. Right? That is known as the galactose. Okay. Okay, this is our glucose given here. Whenever we are discussing about the structure of galactose, you can see that in the fourth position, right? In the fourth position. In the case of fourth position in the glucose, it is HOH, right? HOH. Now, if you are discussing about the galactose structure, you can see that here it is OHH, just opposite. So, which means that galactose and glucose having the almost similar chemical formula as well as structure. The only difference is that in the fourth position, there will be the different configuration of H and OH. Is that clear? So, that term we can call it as epimers. We can call that galactose is a 4 epimer, position in the 4th epimer of glucose. Galactose is a 4th epimer of glucose. Yes, it is a type of isomer. We are called it as epimer. Clear? Again, lactose contain galactose and glucose. So in between here, this is the first carbon, this is the fourth carbon, right? So in between the first and fourth position of galactose and glucose, we will get a glycosidyl linkage. So we can say that there will be a 1,4 glycosidyl linkage. 1,4 glycosidic linkage is present in between the galactose and glucose in the case of lactose. Clear? Now, biomolecules is a simple chapter. You just need to remember some terms. That's only. No need to worry if you are a math student or else biology student. Fine. Again, this is a reducing sugar, which means that it will give the results with the Felling's reagent as well as Tollens reagent. Now, we will be moving to the third type of disaccharide, that is the maltose. Right? Maltose. It is obtained from the starch by hydrolysis using the enzyme diastase. Okay, this is our starch. Whenever we are doing the hydrolysis along with this particular enzyme diastase, it will combine or convert it to form maltose. Then maltose again undergoing reduction or undergoing the reaction to form along with the enzyme maltase, it will form glucose. 2 molecules of glucose. So we can identify that the monosaccharides which is present in the maltose is 2 molecules of glucose. Right? 2 molecules of glucose. Right? These are the 2 molecules of glucose structures. Whenever they are combined together, there will be the glycosidic linkage formed between first and fourth position of glucose atom. So we can say that there will be a 1,4 glycosidic linkage between 2 glucose molecules in maltose. Clear? Yes, 1,4 glycosidic linkage. Okay, is it fine? Can we move to the polysaccharides type? We have to discuss about the structure of polysaccharides also. We will be starting with our starch. Okay, polysaccharides act as the reserve food for plants as well as animals. The general formula of the polysaccharides is C6H10O5 N times. General examples are starch, cellulose and glycogen. Starch, cellulose, glycogen, dextrin, etc. Right? Then let us start about the starch. Start about the starch. That is, starch is a polysaccharide of alpha D glucose. Alpha D glucose. And it is also called amylum. You need to remember some of the terms. Okay, fine. If you are feeling any of the part very difficult, keep on practicing that. It will be the better thing to score maximum, right? If you are feeling difficult in the amino acid part, just keep on revising, keep on practicing, keep on drawing the structures, right? Okay, here starch is also called amylum. It is widely present in the case of vegetables. Now, it is a major food material and easily hydrolyzes with enzyme amylase. present in the saliva of grazing animals, finally gives glucose. Right? This is a simple introduction about the starch. We will be discussing in detail about the structure. Okay. Starch is a white amorphous substance, right? Polysaccharides are amorphous in nature and it is almost insoluble in cold water, right? Insoluble in cold water, but it is soluble in boiling water, right? It is soluble in boiling water. Now I hope you must have an idea about the iodometry and iodometric titration, right? Whenever we are discussing about the iodometry and iodometry, I have already given an idea about the indicator is using, that is a starch indicator. So we can keep on reminding that topic here also. Starch solution that gives a blue color with iodine. Starch solution gives a blue color iodine which disappears on heating and reappears on cooling, right? So whenever the starch is combining with the iodine to form, there will be a complex formation is happening, so it will form the blue color. Next, the starch on complete hydrolysis give D-glucose units. For example, if I am taking the starch here, I am doing the hydrolysis along with the enzyme diastase, right? So it will form the maltose. Maltose again undergo hydrolysis in presence of these enzyme maltase to form D-glucose, right? Okay, this is about the hydrolysis of starch. It will produce glucose. Now, starch is a reducing sugar because it reduces tolerance reagent and filling solution. So it is a reducing sugar. Cannot reduce, right? Cannot reduce, which means it is a non-reducing sugar. Starch cannot reduce tolerance reagent and filling solution, so it is a non-reducing sugar. Next, whenever we are discussing about the structure of starch or discussing about the starch it contains two type of compounds, that is, one is amylose and another one is amylopectin, right? 15 to 20% of amylose and 80 to 85% of amylopectin is present in the case of natural starch. Yes, it is non-sugar, right? There is no any taste of sweet. Now we will be discussing about the structure of amylase and amylopectin in detail. What do you mean by amylose? The combining compound in the case of amylose is D-glucose, which is the alpha D-glucose. So it is a linear polymer. Whenever we are combining all the D-glucose in this straight line chain, right? Straight chain, you can see that it will be forming the amylose. If anyone have about the glycosidic linkage here, whether it is 1,2, 1,4 or any other glycosidic linkage. This is one part of glucose, this is another glucose, this is another glucose. So whenever they are combined together, you can see over here the first carbon of the first glucose combined with the fourth carbon of the another glucose to form a glycosidic linkage here. So it is known as the 1,4 glycosidic linkage. Again, 1,4 glycosidic linkage is present in the case of amylase starch. Clear? It's 1,4, not about 1,1, right? Okay, we are starting from the numbering here. 1, 2, 3, 4, 5, 6, right? Similarly, this is also same glucose atom or glucose molecule. So starting from here 1, 2, 3, this is fourth one, right? So this will be the 1,4 glycosidic linkage. Is the thing clear? Yes, fine. Now we will be moving to the structure of amylopectin, another part of starch, right? Amylopectin. It is little bit complicated. I need your complete attention here. Okay, amylopectin is a branched chain polymer. Amylose is the linear chain polymer, but here it is the branched chain polymer. Branched chain polymer of alpha D glucose. Only the difference is that the previous one is the linear chain polymer. Here it is the branched chain polymer. So, amylopectin is water insoluble and does not give blue color with the iodine solution. What about amylose? It is water soluble and it will give blue color with the iodine solution. Now, just discuss about the structure here. These are the glucose molecules, right? These are the glucose molecules. We are just numbering here. Right? There are two types of glycosidyl linkages are present here. First one, it is that whenever they are combined together by linear, right? Linear, it is forming 1,4-glycosidic linkage. 1,4-glycosidic linkage. Hi Amit and Swastik. The first type of bonding is the 1,4-glycosidyl linkage, right? Here it is the first carbon, here it is the fourth carbon, combined together to form. By the release of water molecule, it will forming a 1,4-glycosidyl linkage here. Now, if you are going through the branched structure, right? Branched structure, you can see that this is the first carbon, this is the sixth carbon of the another glucose molecule. So, they will again form the glycosidyl linkage. E is known as the 1,6. Not about 1,5, it is 1,6. Starting from here, right? 1, 2, 3, 4, 5. This carbon, the carbon about the CH2OH, this is the sixth carbon. So, it will form 1,6-glycosidyl linkage here. Clear? So, whenever we are discussing about the structure of amylopectin, instead of one glycosidyl linkage, they must contain two type of glycosidyl linkage. One is a linear chain of 1,4-glycosidyl linkage and another one is the branched chain of 1,6-glycosidic linkage. Both are present there. Clear? C1, C4 linkage to form linear chains and branched chains are due to the formation of C1 or 6 of a glucose in the adjacent chain. Clear? Next, it is about the cellulose. Cellulose again, it is another type of polysaccharide. It contains beta D glucose, 2 beta D glucose combined together. 2 beta D glucose combined together. So, you can see over here, these are the structure of beta D glucose. Again 1,4-glycosidyl linkage. Again 1,4-glycosidyl linkage of beta D glucose. Beta D glucose of 1,4-glycosidyl linkage is present in the case of cellulose. Right? Clear? And these are colorless amorphous solid insoluble in cold water. You must have an idea about what are the glycosidyl linkage present in each of the molecules along with their position 1,4, 1,6, 1,2 like that. The last one, it is the animal starch known as the glycogen. The carbohydrates that are stored in animal are known as the glycogen. Otherwise, it is known as the animal starch. Clear? Okay, these are about the carbohydrates. We have studied about the classification also. I have given some importance of the carbohydrates here. You can just go through the PDF here. Then, I hope it was clear for everyone. That's all about from my side for today. We have just discussed about the starting of carbohydrates. We have seen the classification of different carbohydrates, right? Starting from the number of hydrolysis products, then the relative configuration and the structure of compounds, right? Okay, tomorrow we will be discussing about the structure of carbohydrates along with the structure of glucose and fructose in detail. Okay, till then, bye-bye all of you. We will try to focus on more JEE Main questions also. So, don't forget to subscribe our channel. Please do like, share and subscribe. Then, till then, bye-bye all of you. Thank you so much.